I'm delighted to introduce Neha Sardesai. Neha Sardesai is a senior education application engineer at Mathworks. She partners with university customers to understand their technical and business challenges. Her primary objective is to drive the adoption of Matlab, Simulink, and other Mathworks flagship products in various domains, including curriculum development, research projects, and commercial applications. By showcasing the versatile applications of these powerful software tools, she helps universities leverage their capabilities to enhance learning outcomes and drive innovation. Neha got her PhD in electrical engineering from the University of Maryland, Baltimore County in 2016. And ever since then, she's been doing phenomenal activities. So she has a career spanning 6 years at Mathworks. She's gained extensive experience in understanding customer needs and tailoring solutions to meet their unique requirements. Her dedication to fostering strong relationships with university customers has been instrumental in driving the successful integration of Mathworks products into their educational programs. With that in mind, Neha's workshop is entitled Low Code, No Code AI. She will take questions throughout her talk, but also in the Q&A panel. She'll share links to code and other resources, both during the talk, I believe, and after. With this in mind, please welcome Neha, and thank you for joining us today.
Thank you, Lou. That was such a nice introduction. Thank you very much. I will start sharing my screen. All right. So thank you, Lou. That was a great introduction of myself. I'm going to go home feeling very, very satisfied and, good about myself. Hello, everybody. My name is Neha Sardesai. As Lou mentioned, I work as an application engineer in education here at Mathworks. So we're going to do like a bottom line on top kind of a situation with our presentation, a workshop today. What are we doing? So if you look at a slide that I have on screen, it's essentially we are going to sort of mimic our smartwatches. Now, I have an iWatch on. I'm sure you have some form of a Fitbit, iWatch. If you haven't used it, you've seen it. You know how it works. What I'm going to try to do and what you're going to help me do today is we are going to try to identify, based off of some information and some data that we've already pre-collected, whether we are sitting down, standing up, or walking. And we can have many more buckets. So that's what we're going to do today. And we're going to use AI for this, and hopefully as minimum of code as possible. So to keep it as no code as possible. All right. So we basically want to make at Mathworks AI accessible to everyone. We understand that, AI, it was something that came in many, many, many years back. And I will be talking about a brief history of AI. But it's also understandable that not everyone comes in with the expertise that is expected when you want to talk about machine learning, when you want to talk about deep learning, different neural networks. What do you implement? How do you implement? What kind of a network would make the most sense with the data set that we have available? It's all a little daunting sometimes. So the way I like to talk about this is that we want to make AI as accessible to someone who's just getting their feet wet into it conceptually and syntactically, no matter what tool you're working with. And this is what I want to help you do today. Okay, so I have my, if you want to approach me, if you want to talk to me, later post this presentation, the best way to get in touch is via LinkedIn. This is my link, and the slide deck will be shared post the presentation, post this talk as well. So you will have access. And for our agenda today, we'll go a little bit over the fundamentals of AI, just as I mentioned, getting our feet wet conceptually. And then what I want to do is we're going to do 3 examples. The exercises are arranged such that there are 3 examples. One, where with our data set that we have available, I like to call it my activity data set, which is essentially this researcher who I've actually cited in the slides as well, put a cell phone around his waist and walked around, laid down, stood up for a while. And then so we have all of this data that we have, and then we're going to classify it. We're going to use it with unlabeled data, that is, just going in blind, just like our iWatch does sometimes. And I'll talk about that in detail as we go along. Then, if time permits, we'll go into classification using your traditional machine learning methods. And then again, we'll look into how you can work with deep learning, all from a low code, no code perspective. Okay. And of course, I'll talk about some further resources as well. So If you have any questions, definitely post them in the chat. If I see them, I'll just answer them ad hoc, or if I miss anything, I'll probably ask, probably Lou will ask me afterwards. I'm going to leave about 10 minutes. I'll talk for 15 minutes, and then the last 10 minutes of the session, I will leave for Q&A exclusively. Okay. What are you going to learn out of this? What are you going to take back with you today after listening to this session? Whether you're an expert in the AI domain or whether you're just coming in, just trying to understand what this is all about, you will get some fundamental basic knowledge about what AI is. You will understand how to use, design, and train different models with interactive tools in Matlab. Again, the highlight is low code, no code. And finally, I will show you how you can automatically generate code. So the code is there, but you're not writing it. Matlab is doing it on your behalf. Okay. All right, let's jump right in. Okay. What is AI? Artificial intelligence. Back in the 50s, so let's take a little bit of a history lesson here. Back in the 50s, researchers were working with artificial intelligence, basically defined it as any technique that is enabling a machine to mimic human intelligence. Now, kind of makes sense based off of the way it was named. In the 80s, when machine learning was more, prominent and people were doing much more research and identifying ways in which to get deeper into the whole machine learning perspective, defined it as statistical methods that are enabling machines to learn tasks from data without explicitly hard coding it or programming it. Okay. And then finally, in the 2010s, which I now realize was about 10 years back, is deep learning, which is neural networks. So these were based off of multiple layers representing that learn from tasks directly from learn the tasks directly from the data. So we'll differentiate between all these in a while. But the way I like to think about it is artificial intelligence, if you're looking at it from a set perspective, is like your whole universal set. A little subset is machine learning, and a subset of machine learning is deep learning. Okay. Now we're going to go into the types of machine learning. So now if you want to define it in your head, it's essentially teaching your algorithm to do a certain task without explicitly specifying it. Okay. So let's take an example of our activity data, right? We are going to have this activity data, and we are going to be, in today's example, clustering it. Now, this is unsupervised. What does unsupervised mean? I'm going to give now the example of my iWatch. You can extrapolate it to your Fitbits and any of the other. I think Motorola has a smartwatch as well. Ultimately, it's doing the same thing. When you put it on for the first time, it has some basic defaults that have been set. Let's just talk about walking and sitting down. Okay, for now, we're doing two buckets, two classes, sitting and walking. Okay, so when I'm actually walking, it is going to be understanding how my accelerometer data, accelerometer is a sensor, which is measuring your acceleration as you walk or not. Now, meters per second square, essentially. Now, it's going to get this information from my sensor in my watch, and it's going to tell it, and it's going to learn from it. I'm not telling it that, listen, buddy, my gait is X. I tend to bounce this much. When the acceleration is above this is when you're going to count it as walking. It's not doing any of that. It's learning based on what data it's getting. Now, if I'm standing right now, so if I'm standing or if I were sitting down, it would understand that, okay, she is sitting down because her acceleration is about 0, but it's interpreting it based off of the amount of data it collects. Okay, that's essentially unsupervised learning. Now, there's different ways in which you can do this. Clustering is one of the most standard ways to go about it. So like, for example, you're segmenting your data based on data similarity. So for example, if my acceleration is below a certain value, you classify it as sitting down. Whereas if it's above a certain value and if it's staying there and if it has a little bit of a bounce to it, it means I'm walking. Okay. You can see in this diagram on the slide deck over here, you can see how there are different ways in which you can do it. There's hard clustering models, there's soft clustering models, and then it gets complicated as you go along. Okay. Now, this was unsupervised. So what is unsupervised? You're discovering an internal representation purely from your input data. Okay. Now let's talk about supervised learning. Now, supervised learning in this case is you have a predictive model that you're developing, which is based on your input data as well as output data. So you have certain data that is labeled, that is corresponding to your output that you're looking at. So in our example with the activity data, it will have a label associated with it. This value corresponds to walking, this value corresponds to sitting, this value corresponds to standing, so on and so forth. And you train your model based on the input and output, and then and from that, it will be able to interpret and tell you without looking at, without cheating and looking at the previous data that, okay, you're sitting or you're standing or you're doing whatever. Okay. Now, there are two types of supervised learning: regression and classification. Regression is for continuous data, for example, weather prediction, stock market prediction. And your classification is essentially classifying things. So you could put them into different buckets of, let's say I want to classify images. When you go on, you're trying to log into different websites and they give you this "I'm not a robot" condition where you have to look at a grid and mark all the signals in the image. So that's essentially you classifying into signal, not signal. So something like that. Okay. And of course, there's a category, a whole slew of algorithms that are associated with each of these supervised, unsupervised learnings, regression and classification, and so on and so forth. Notice that deep learning tends to cut across machine learning. As I mentioned, deep learning is a subset of your machine learning. It is working with neural networks. Now, what's the difference? Yeah, why do we have to have a separate classification? Why do we have to have a separate naming system, machine learning and deep learning? What does that mean? Now, this slide sort of illustrates a way in which these things are different. Okay, machine learning. Let's take another example. I have multiple images of vehicles. Now, I need to classify them into car, truck, and bicycle. Now, in case of machine learning, I, as the user, as the programmer, I'm going to point out to my model that, hey, I want you to look at this feature in order to determine what your classification is. For example, number of tires. Okay. Now, this is a very, very generic example I'm giving. There's much more associated with it, but I want you to just get an understanding of how you can classify these two things. Okay. Now, you have your machine learning. You have, let's say I'm looking at the image of a car. How many wheels does it have? 4. Hence, it's a car. Does it have 2 wheels? It's a bicycle. More than 4 wheels? It's a truck. But I am telling the model explicitly that, buddy, I want you to decide, I want you to look at the number of wheels. When I'm doing deep learning, however, I don't need to tell my neural network that look at this feature, look at that feature to classify correctly. It's going to understand and decide on its own what features it's going to look at and hence classify. All right. Now, for machine learning, domain knowledge is extremely essential. You need to know what you're doing. You need to know what you're classifying or building a prediction model for. Whereas with deep learning, yes, domain knowledge is always appreciated, but you also need a lot of data with it. A lot of data. Okay. The lesser the data, the worse your model is going to perform. All right. So we're going to jump right into our workshop now. We're going to jump right into our workshop right now. So we are going to do human activity classification. We have our data. As you can see, our data corresponds to standing, climbing up the stairs, sitting down, just standing, walking, and laying down. First case, we have no labels available. We are going to go in blind and do clustering. If time permits, we'll go into machine learning and deep learning for classification from a classification perspective. Okay. The data was collected. I've cited the link below, and there is a video of how the data was collected as well in one of the files that I will be I'm sharing. Okay, this is where I want all of you to get involved and start working with me. If you plan to go along with while I present, this is a workshop, so it's a hands-on workshop. I've created a license for you. We're going to be working in Matlab. Okay, I've created a tiny URL link. We can, give me a moment. I will post a link to my workshop license in the chat. Okay, so here is the link. This is in the chat. click on it. If you notice, you will go onto a web page that looks like this, okay? Once you go on this web page, click on Access Matlab Online. As soon as you do that, it's going to open another tab, and then you're going to get access to all the workshop materials, okay? You'll have this little window open up. Click on I understand the risks and of saving, and click Save and Open, okay? Yes, you will have access to the account for another week after today to be able to play with the data. Even then, so the files you will have, so since you've saved the files in your Matlab online workshop, you will have access to those as well. So for example, like over here, this workshop, give me a moment. This is, I don't know why the wheel is there, but okay. Yes, you do need to create a Mathworks account. So if you haven't created a Mathworks account, I think there was an email sent out yesterday where you were asked to do it. Even if you haven't, it's fine. Just go to mathworks.com, create account on the top right corner, and then just create your account. I'm going to give everyone, it's 16 minutes past the hour. I'm going to give everyone about 5 minutes to set this up. So what I want you to have towards the end of and I will be doing it with you, so you'll see how it goes. Okay, okay, let's click. Once you click on Access Matlab Online, it will open this folder right here. Give me a moment. Let me open this inner. Yeah, so as soon as you log in to your account, it will let you. So you need to write your email. You need to create an account. It's already giving you an option over here. Create your account. Once you have created your account, you will see your initials right here, like in my case, and you'll have my account, that means you're already logged in. Then what I want you to do is click on Access Matlab Online. Once you access Matlab Online, you will get this open repository link right here. All you have to do is, in my case, I've already saved this, but you will have the option in this case. You just have to click, I understand the risks of saving and running code from outside source. This button right here, and then you have Save and Open. As soon as you're done with this, what will happen is you will be opened up, you have files over here, exercises over here, and this will not be open for you. So this is what the screen will look like. As soon as you come to this screen, I want you to say yes or I'm done in the chat, okay? I'm going to give everyone, so it's 18 minutes past the hour. We're going to wait another 3 minutes. Okay, I see some folks are done. I see a check mark. Yes, I'm done. Okay. At this point, I also want to introduce 3 of my TAs, 2 of my TAs. I hope they're all here. Ahmad Meki, who's joined as an attendee, and Julia Saha, and I believe Harish as well has joined. They're going to sort of help with Q&A. Oh yeah, Harish is here too. So they're going to help with Q&A if posting certain links. Ahmad's here as well. Julia may be here as well. If you have any questions, definitely post them in the chat. They should be able to give you access to whatever, if you need to share, if you need some resources as well. Okay. Okay. Any questions? Anyone having any difficulties with opening this workshop? Okay, it seems like everyone's okay, done. Still working? Yeah, sure. Please take your time. You have another 2 minutes. Okay. So everyone should have access to these files. This particular license for this particular workshop will be available for a week after today. So till next Wednesday. Yeah, it is Wednesday. And after that, you still have access to your files. So because you've created your Mathworks account, you will still have access to your files via your Matlab drive. And you should be able to use them post this license as well. Also, we have you can access Matlab using your own, if you're joining from a company, if you're in a university. Generally, most universities have a campus-wide license. So use your university email ID to log in. And even if you don't have a license, don't worry. Mathworks has come up with this Matlab Online Basic version, which is essentially you get 20 hours of free Matlab access every month for Matlab Online. So you have some way or the other, you will be able to open and play with these files, okay? Or worst case, just download them onto your laptop or desktop. Okay, so it is 21 minutes past the hour. I'm on the East Coast, so I'm saying 1:21. If I'm going to start working with, the workshop. If you have any questions, please post them in the chat, okay? No. So we are now going to jump right into Matlab Online. All right, next question for people. How many of you have never used Matlab before this? So Binish has asked a question if you have access to recordings for these Zoom sessions. I believe these will be posted on YouTube in a few days. So you will have access. Okay. All right. Cool. I see a few people who have never used Matlab before. Well, welcome. This is your introduction to Matlab. I have been using Matlab since I was in undergrad, which was at least 15 years back. Wow, I'm old. Okay, so Matlab is a tool that has been used by engineers and scientists for doing all sorts of fun stuff with essentially anything and everything. So Matlab stands for Matrix Laboratory. So originally, it started out as a way in which you can work with controls and optimization for matrices. Of course, the natural progression of that was image working. Harish has posted a fantastic video in the chat about Matlab, an introduction to Matlab. Let me just sort of give you a brief overview of the real estate of Matlab here. So this is Matlab Online. This Matlab is hosted on our servers. There is a local version available as well. If you look right here, this is my latest version of Matlab. I will not open it. The way we have arranged it, this looks very similar in the local version as well as the actual online version of Matlab. If you go from left to right, you will see this is where your files live. Here is where your workspace is where all of your variables go to live. So for example, this is my command window, which I like to call my scratch pad. So whenever you're trying to do something, or you just want to do something really quick and understand a few things, you can use your command window. So let's say I want to create a matrix, 4x4 matrix. I can create it this way. Now, let's say I want to replace all the values that are above 10 with a 0. So I create an index saying mat greater than equal to 10. So what I created now is essentially a logical array or logical matrix, which essentially corresponds to the true or false for my condition, which is, let's go line by line. Is 16 greater than 10? Yes, it is. So we have a 1. Is 2 greater than 10? No. So you have a 0, and so on and so forth. And then let's say I want to replace all of the values that are greater than equal to 10 by 1000. I say mat of idx equal to 1000. And there you go. So this is the way in which you can play with Matlab. There's so much more you can do. We call this method logical indexing. Okay, we're not going to be working with this particular way. I was just showing you what you can do with Matlab. Now you have your editor window right here. which is going to house all of your rich text, all of your code, as well as images and so on and so forth. It's a notebook format. And finally, on top right here, this is what I like to call the best part of MATLAB, which is our tool strip. Anytime you want to do anything with MATLAB, just go to the tool strip. We generally have a button for it, is what I like to say. And of course, if nothing else, we have our documentation. We have a very dedicated documentation team, which keeps good tabs on writing stuff up. And we will go check it out. I have a question in the chat. To execute, what is the shortcut? In the command window, I just write my command and hit enter. But within my editor window, control enter, or you can click on this little green blue thing here as well. Okay. All right. So 26 minutes past the hour. All right. I'm going to now jump right into our, no, I'm going to put this back down. All right. We're going to jump into our human activity clustering. Remember, we are classifying our activity data set to see what it looks like, to define if a person is standing or sitting or walking. Okay. Now, there's a bunch of, here is a link to the video. I'm not going to show it to you, but how the data was collected if you're interested. You can, if someone can copy that link and post it in the chat, if someone is interested in taking a look, that'll be great. We're going to start with a little bit of housekeeping. So it's always good to make sure that, you're in the right directory, you've cleared out your workspace, everything is, hunky-dory to start off. So clean slate. I'm going to ask you either hit control enter, or the way I like to do it is with my mouse with this blue little ribbon on the side, on the left side. You can just click on that and it runs that section of the code. So I'm going to ask you to go ahead and hit on that. And if you're in the right directory, what I want you to do is you go in. I'm sorry, where am I? Fine. Oh, yeah. In low code AI, you'll have exercises, double click and go in there. What I also want you to do is and then I want you to run this. You should say you are in the correct directory. Please continue. As soon as you get this sentence, please say yes in the chat. Okay, so this is what I want you to do. When you had opened, this is where you were, right? With the human activity recognition. I want you to double click on exercises. So you're in the exercises folder. Now what I want you to do is, I want you to, I should have started with open human activity clustering _work. So double click on that, open this file. Okay, once you open this file, I want you to scroll down, come to your first section right here called housekeeping, and run this section. If everything is right, you will have this line in the end that says you are in the correct directory. Please continue. If you get this, I want you to write yes in the chat. Okay. And if you haven't got it, please write the answer that you're getting in the chat. Okay. Jordan hasn't got. Jordan, what are you seeing are you seeing please navigate to the proper directory as the line over here? Fantastic. So you're not in the right path, in the right directory. Okay, so, all right, okay. So we have to run this bar right here, this blue, or if you want, you can go to live editor and say run section. Okay, or as Harish mentioned, you can press control enter. Okay, how to navigate to the right directory. So you go inside, you are going to be in the low code workshop, double click on exercises. That's the directory you want to be in. So Liz, did you get it the way, based on how I instructed? Because I see Liz got it. Yes, okay, so that worked, great. Okay. I'm going to wait for 2 more people to say that they've got it, 2 or 3 more people, let's say. Okay, worked, that's 1. Come on, folks, 2 more. And then we can move on. Then we're going to go to the fun stuff where you don't have to write any code. Cannot find your human file. What? Okay. Jian, do you have access to the folder? Okay, so I need you to go in. I have a Q&A as well, I think somewhere. I have a question in the Q&A, which I will answer at the end of the session. Okay. So just somebody who has, I think, I don't know who has sent the question, but I will answer your question, but that's one of the questions I'll answer last. Okay. All right. Okay. So I have people who are fairly on point. Okay. Let's move on. Let's go to the next bit. So now, whenever you're working with any form of a data analysis problem, AI falls under data analysis. Ultimately, you're coming to some conclusion with it. The first step is always accessing your data, loading your data. Now, in this case, you have what we are going to do is we're going to import our data. Again, this is low code. So we are not going to write any code here. What we are going to do is go to Home tab, follow along, Home tab. There's an import data button. Okay, and I'm going to show this to you twice. So follow along for the first time. If you don't get it, I'll do it again. We hit import data, that button. All right. Now we go into an import data. You'll see additional files has come up. Open it. We're going to do raw sensor data underscore train. That's the one we are looking for. Okay. And then we hit open. Now you can see that I have 7 rows. Body underscore gyro X. So gyroscope data along XYZ axis, accelerometer data along XYZ axis. And there is a categorical data called train activity. And I will explain that in a moment. But what we are going to do right now is we are just going to say import. And then we will have our workspace populated by all of these variables. Okay. Now, if you have done this, if you have all of these variables in your workspace, I want you to say yes, or a thumbs up, or a check mark, whatever in the chat. Okay. So I'm going to do this again, right? Yep, there. Ahmad has, thank you, Ahmad. That was really cool. You go to home, you go to import data, you expand additional files, raw sensor data underscore train dot mat. Dot mat is the file format that we save Matlab files in. It's like any .txt, .xls, similarly .mat. It's just a file format. And then you hit open. Now, once you get your data, we already have all of the data selected, and we are going to hit import. All right. So let's take a look at our data here. I'm going to open the train activity, the last one, train activity data. That's what we're going to open. So I've double clicked on it. You need not do it, but if you want to follow along, go ahead. This is like an optional thing. Anytime, buddy. There we go. So if you notice, my categorical is essentially my labels of standing and sitting. So all of my data that I've collected is going to be basically these categories. A category is nothing but it's a variable, it's a data type that we have in a data container in Matlab that you can, it's, as the name suggests, it's a category. All right. Similarly, now if I look at, let's look at my acceleration data. Now this is a huge data set. Okay, it's 128, 7352 by 128. Okay. So, okay, we've got our data into Matlab. Next steps. We have to pre-process our data. Now, so each row, read the text as well, because there's a detailed explanation of what's going on. Each row represents one observation. 128 data points are 128 columns. And we are going to find clusters by grouping similar rows. Okay, that's what we're going to do in the future, like for the clustering perspective. Now we need to pre-process our data. Now remember when I said for machine learning, you need to know what the features are. You need to tell your model that, look, buddy, this is what I'm looking for. And that's where your domain knowledge comes into play. So we are going to look at means and standard deviations. Okay, because that's something that we have already decided, and based off of the data that we've looked at before, these are the statistical variables that would make the most sense and give you the most correct predictions. Okay, so again, here all I'm asking you to do is hit this button right here, which is run that section. So when you run that section, you will have activity data train added to your workspace. So what's happened over here is we've just created a single array that contains all of my acceleration means, gyroscope means, acceleration standard deviation, gyroscope standard deviations. Okay. So I'm going to assume you have done that, because the next bit, which is actually the clustering bit, is where I'm going to give you a good 7 minutes to play with the UI that we've created. We call them tasks. It's a lot of fun. So what are we doing? So we have basically prepared or pre-processed and prepared our data so that we can now run some form of a machine learning model on it. Okay. So I've created my variable called activity data train. Yeah. So we're going to be using something called k-means clustering. Now, if you can, I've provided a link to the Matlab documentation. So this is the actual function that is being used. As you can see, we give syntaxes, we explain, we have examples, and there's a lot going on here. But if you scroll towards the end of the page, there is also something called topics, which is you can compare clustering solutions, you can look at an introduction. So we not only tell you how to use Matlab syntactically, we're not only teaching you the grammar of the language, but we're also teaching you concepts of what you're trying to do. Okay, so there's a whole section on k-means clustering with an example and so on and so forth. Yeah. All right, so I'm not going to go on to explain k-means clustering. All it's going to do is, in this case, it's going to pick any 3 arbitrary points and find the nearest neighbors. And then based off of that, we're going to have 3 clusters. Okay. So now what I'm going to ask you to do, okay, this is the best part. This is like most important part. Okay, we're going to have a lot of fun with this. I want you to bring your cursor, click right here under insert live task here. So I need you to make sure that your cursor is over there. Then I want you to go to the live editor tab. Okay. Then I'm going to ask you to go to task. Then I'm going to ask you to look at AI, data science, and statistics. That's the 6th section you're looking at. And you're going to look at cluster data. I'm going to ask either Ahmed or Julia or Harish to put Ahmed, whatever you did with the import data, the same thing. If you could do that, that'll be great. Okay. So make sure you click under insert live task, go to live editor, go to task, select cluster data, and it's going to insert an interface, a task, as we like to call it, for clustering data. Now, what do we do? We're going to select an input data. What are we going to select? Activity data train. That's the variable that we're going to use for clustering. Okay. We've prepared it accordingly. Now I'm going to say cluster indices. That's it. Make sure that the variable is called cluster indices, centroids. Okay. Now we've selected our data, which is activity data train. Now we're going to select the number of clusters. Now we can decide, we're going to stick to manual. We're going to do 3 clusters here. Okay. So I'm picking 3. What are my 3 clusters? The computer doesn't care. Matlab doesn't care. It's just going to give me the most optimal 3 clusters. It's going to be sitting, standing, and walking. Okay. So we're looking at 3 clusters. And then we're going to, if you want, you can specify optional parameters like how are we looking at distance, number of replicates, how are we starting? Are we going to, number of iterations and so on and so forth. We are going to leave it as it is. Mia has asked a question, where do I find the insert live task? So if you scroll down in your thing, there you go. Thank you, Julia. Now what we did here is we input data, activity data train, manual method 3 clusters. And now I'm going to run this section. Okay. Let's give it a moment. Et voila. So we have 3 clusters created. Okay. Amarchi, Julia has actually posted right a few chats above. You go to Toolstrip, Live Editor, Task, Insert Cluster Data. There's a Q&A question, and I'm answering it live right here. Can you perform data cleaning tasks on Matlab with no code? I will answer it. Give me one moment. I'm going to let everyone play with this clustering for it's 40 minutes past the hour. I'm going to give you 5 minutes to play with it. What I want you to do is I want you to understand what you're doing here. Like, so you see, you have 3 distinct clusters over here. Okay. So play with it. See what happens if you do city block distance, for example, and then run the code. Sorry. See what happens here. Or I don't know, change number of replicates, change a few things around here, play with the data, see what you see what happens. Now, if there's a little arrow button here, and if you expand it, you'll see associated code with it. See, like the code is already being generated based on the pointing and clicking that you're doing. All right. I'm going to minimize it. I don't really want to see what the code looks like at the moment, but you can see how the clustering has happened. Okay. I'm going to give everyone 5 minutes to do this. I'm going to come back in 45 minutes past the hour, and I will answer a few questions till then. So the Q&A I got, can you perform data cleaning tasks on Matlab? Yes, you can. So for example, if you go to live, actually, if you go in Home tab, there should be a data cleaning. Is there supposed to be a, well, not here then, Live Editor. Under tasks, there is a clean missing data pre-processing option that you can do. So you can use that as well. So yeah. Yes, let me post the link to the tutorial. I see that there is a... Give me a minute. There you go. I just want you to make sure that your variable over here is named cluster indices, not cluster indices 2, because for the follow-up code is connected to this, okay? So make sure it's cluster indices. Okay. Thank you, Harish. There is a data cleaner app which is available in the local version of Matlab. Let's see if mine opens up. But it's not on Matlab online, but you can, yeah. So everyone has about 2 more minutes while we do this. So this is what the local Matlab looks like. So basically, if you check right here, there's a clean data button. So if I click on that, it will open up another. So usually all of these apps, so we have 2 types of UI, no code, low code UIs that we have. One is the tasks which you can insert into your notebooks, or one are these apps which are external UIs. I mean, like separate windows, if you want to think of it that way. So with these separate windows, these apps that we call, there's generally always a generate data button associated with it, which is going to, as the name suggests, generate code for it. So as you can see, I have to import some form of data over here. I don't have anything here, but but you have an option of cleaning missing data, cleaning outlier data. You can normalize, smoothen, retime data. And then there's an option to export here. When you like expand it, you get an option of generating code associated with it. Okay. Okay, what else do we have here? When I attempt to do clustered data, it asks me to select data, select number of clusters. Yes, you do have to do that. So for example, right here, I selected activity data train, right? So that's because I had run the previous section where I have prepared my data to be in that activity data train variable. Now, when it's imported, I make sure my selection is manual and I select the number of clusters as 3. So make sure you do that and then run this. You can also take a matrix of scatter plots, because why not? There we go. So this is a comparison of columns in clustered data. Probably don't want to look at that in that much detail, but why not? Here it's just the first and second principal component that we're looking at on X and Y. Okay, so I think we've moved on beyond our the amount of time I've given. I hope you had some time to play with this app that we created. So we're going to go to the next step. Now we've done evaluation of our model. We've clustered our data into 3 sections. Ultimately, if you look at what we are doing, we're using the cluster means function, right? And then we're just plotting it. So from here onwards, we are plotting the data. For this, we're just doing the cluster means. We're just like doing clustering in this case. Okay. K-means, sorry. What am I saying? We're doing a K-means on that, which is the link to the function that we had above there. So we need to evaluate this model. So it's great that we've clustered this. Yay, great, good for us. Now, what do we do when we actually have newer data coming in? We need to be able to classify these, right? So how should you do that? So we're going to run this section right here, and we're going to see, so we're going to get some train activity. And then we're actually going to see what it looks like. So what classifies as sitting, what classifies as standing, what classifies as laying down. These are the, and walking. Okay. There are 6 classes, and we're actually comparing it against our sort of cheat sheet that we had. Remember when we looked at that activity data train, the categorical, that is what it was. Okay. And that's about it. So this is how you're going to be running clustering in Matlab. Okay. So I'm going to go back to my slide deck. You are more than happy to pursue some more stuff. Let me just introduce you to the next 2 steps because we don't have the time to pursue it right now, but I want you to take a look. The second thing is called human activity classification _ML, and that's for machine learning, and _DL, that is for deep learning. Yeah. So when you go down here, you're doing basically the same thing. The only difference is you're going to use a classification learner app. So let me quickly run this. So we have all of this data imported. So I have my all of my data that I've imported. I'm again looking at means and standard deviation. You see, I'm doing mean, standard deviation, creating my activity data test, right? And now the only difference what I'm going to do is I'm going to be using this classification learner app. So I'm going to go to my apps tab, expand that. Under machine learning, I have a classification learner app. And I'm going to ask you to not follow along for this just out of the interest of time. So I just can quickly show you what we do with this. Yes, I have a question okay, I'll answer the question in a bit. We are going to import, so I'm going to import my data from my tool strip, from my, oh my God, workspace, sorry. I'm going to use activity data test for now. I just need a smaller data set out of the interest of time, in the interest of time. Yeah. And something was wrong. That's what happened. Activity data train. And then when I went, 1 second. Well, activity data test, right? Ha, this is what happens. So essentially what I'm going to do is I need to import from workspace. Why don't I have a... I need to pick out my response from workspace, which is my test activity. So my test activity is my categorical. So I need to ensure that I have I need to know what I'm classifying as. This is supervised learning. So we already have our labels associated with our data. And I'm going to do a quick to train. I don't want to use parallel for now. Training. What am I doing here? I know I'm going a little fast. For classification learner, I already have my data, which was my means and my standard deviations. What I've also given this app as an input is the categories associated with my input data. So if my mean is X and standard deviation is S, there is a category associated with it per timestamp of all the data that I've collected. So I'm giving that as an input also, and I'm training different multiple machine learning models using that. So for example, this KNN, I have trained 11 models right now, or 12, right? Machine learning models. This one, KNN, fine tree KNN, has the best accuracy. Now I can look at its confusion matrix and see that of the 6 categories, it's doing a fairly decent job with classification. The walking is a big issue. Sitting, standing is a little tricky, but it definitely gets laying down 100%. Okay. And now I can export this as a model or generate a function associated with this. Now, when I generate this function, Matlab has written code for me right out of the box. So it's written an entire model for me, which is being trained for fine KNN. And it's all, I mean, I haven't written a single line of code in this case. I want you to explore this in further detail. There's a lot of instructions written down on how you can go about each step by step, how you can evaluate the model as well. And then you can play around with it and with the data set that I've provided. Okay. I'm going to answer one question from the chat, from the Q&A. Can we use Matlab to also plot graphs instead of using the matplotlib or pyplot? Yes. Fun fact, matplotlib was actually sort of inspired by our MATLAB plotting directory. So MATLAB plotting library, so matplotlib. So we do have fantastic plotting tools available, and I would be more than happy to, post this session, of course, walk you through some ways in which you can plot with MATLAB. Okay. So let's get a recap. We basically use clustering to label raw data. We looked at classification learner. I showed you just a brief overview of how you can use classification learner for classifying your data. And if you want to work with deep learning, you can go into this third file that is available in your exercise files, which is for deep network designer. And it's a fantastic way in which you can design neural nets. There's a great way in which you can drag and drop different layers and make it your own and, just go crazy with it. Okay. So you've learned how to use our interactive tools. We have our apps, we have our tasks. We try to make your life easy. We're making AI accessible to everyone. And, interactive tools will help enhance your programming skills. Ultimately, what we at Mathworks want to help you do is achieve the task at hand as opposed to getting lost in the programming. And I'm hoping this is helpful. So for further practice, you could try different clustering techniques. You can improve accuracy of different models, and you can try to collect your own data to exercise with. We have an app that you can use on your phone called Matlab Mobile. You can access your accelerometer from there, and you can run around, walk around, lie down, and then use that data to play with for clustering and for machine learning. Make it your own. We also have we have online trainings available if you're interested that are self-paced, and all you need is your account and you can access them and play with, understand and learn more about machine learning. That's it from me. My name is Neha Sardesai. I know I went a few minutes over, but I hope this was helpful. And, I will now take any questions that you have. I already have 2 questions in the Q&A, which Lou, would you be reading them out and I'll answer them?
Yeah, sure, if you'd like, or we can be
Sure.
very flexible. So first of all, thank you very much, Neha, for the wonderful workshop. And I'm looking through the chat, and people are so happy about the content that you shared
Thank
with
you.
them. So
Thank
thank
you.
you. And here are two questions. I know we left the first question for a little bit later. I'm actually going to go
Yes.
with the second question, and
Sounds
then we'll
good.
go with the first question. So here's
Yeah.
the second question. In place of clustering, can we also use decision trees to classify the data?
Yes. Short answer. Long answer also, yes, you can.
Yeah.
It's ultimately up to you and the data that you're working with. It's somewhat of a trial and error. And this is also where your knowledge of machine learning and like conceptually helps you to decide these things better. But ultimately, you can again go through the trial and error way and just figure out whichever makes the most sense to you.
This makes sense. And then
Yeah.
this question almost feels like a plant question, but long story short, what advantages does MATLAB have over using Python or R for machine and deep learning?
Okay, so this is a very loaded question. I'm going to try to answer it to the best of my ability. Please understand, this is also, I'm not talking on behalf of the company. There's a bit of personal preference over here as well, which is my first point. It ultimately depends on what you know. Nobody is insisting that you have to learn one over the other or both together. Whatever makes sense to you, go for it. The reason I find MATLAB more helpful and more useful is as a user, we have, I mean, we're a company where you're technically paying for the software, but you're also paying for other services that, like me as an application engineer who works with, or Lou also, who is an AE who works in a vertical specifically. I work on a more generic front with education. I actively go out and talk to professors, students, see how they're using the tool, and understand if they need any form of, I don't want to say help, but help to figure stuff out. So we are dedicated technical resources. Ahmad, Harish, Julia, who are also on the call, they are also fellow AEs and edu. So we tend to have that personal relationship that we do establish, which tends to help out a lot. I like to call it shallow consulting. Also, you can call in to our tech support line anytime, and then you get some help on that front also. So that's essentially the help part of it. Documentation, we have a very intense documentation team that makes it a point to make sure that everything is explained perfectly clearly, hopefully that again, we try to make it such that I was on the doc team, so we tend to do that quite a bit also. And I think MATLAB is just easier. As I said, you can get away with not knowing how to be the most efficient programmer and coder. Also, scaling can be easy with MATLAB as well, especially if you are not from a CS background. So with stuff like this, so it's a great engineer's tool as well. And again, with the low code stuff, why write code when someone else is writing it for you, even if it's MATLAB, right? And we ensure that it does it correctly. Like, it's not, we have a lot of QA and QEs in to check the quality of the code that's being generated also. So yeah, that's my
And
answer.
yeah, and and this is great, Neha. And I love the fact that you highlighted that, you know what, we can all coexist. And in terms of
Yeah,
choosing those tools, there's a lot of factors to consider.
yeah,
And, this is something I hope everybody in the audience takes away with them. And
yeah.
maybe we have time for one more question. So
Sure,
here's this last question. And any other remaining questions, feel free to type in the
I
Q&A
will. Yes.
panel. So here's this last question. Must this be a classification problem? What if I decide to treat it as a regression problem? Can MATLAB also be used for regression?
Yes. For this particular example, we treat it as a classification. It's a very traditionally classification problem, right? Like, you can only have a standing or a sitting or whatever, but you can do it for regression as well. Like, as I mentioned, we have a fantastic regression learner app as well. So if you go under those apps with classification learner, there is a regression learner. So you can use it we do examples on weather forecasting and stock market prediction as well. We used to do Bitcoin prediction, not anymore because it's all over the place, but you can do it for any form of regression problem as well. So yes, you can do regression too. Yeah.
Excellent. And right on time. Neha,
Awesome.
thank you
Okay.
so very much for sharing your expertise with us.
Thank
And
you.
Neha will share additional resources after this workshop too. So
Yes.
thank you so much, Neha. And thank you to the other math workers as well who assisted. Thank you so much.
Thank you.